Good morning, Kim 1. I want us to do a video on the gas laws. I know you've been looking at other videos and other areas on gas laws. And so what I wanted to do was to go over that maybe in a little more detail and hopefully help you out. So the first one we're talking about is Boyle's law. And essentially it says that as you increase the pressure on a gas, it's going to reduce its volume. And so hopefully that makes sense to you. And so the formula with that is PV equals PV. Now, in some of the videos and stuff you may have seen, they may have it P1 V1 equals P2 V2. I really don't care if you follow this. I've always taught it as PV equals P prime V prime. I'm just trying to distinguish the two, and whatever works best for you. I found over the years that this particular formula works a little better, not as confusing, but if this is less confusing to you, then by all means use it. Also, I have found that my students sometimes like to do better with plugging numbers in and solving for the missing variable, or setting it up to solve for the missing variable and then plugging numbers in. Either way, mathematically is the same. But it does become important to look at units and make sure you're crossing out the right unit. Now, before we actually do a Boyle's Law problem, I need to spend just a minute talking about atmospheres, or pressure, excuse me. Pressure, as you may remember, is the weight of the air pushing down on us. And back we learned in 22.4, we talked about standard temperature and pressure. Well, standard pressure is 1 atmosphere. And what we say is the weight of all the air pushing down on us is called 1 atmosphere of pressure. And that's the weight of the air at sea level. Now, how is that measured? Well, it's measured in several different units. One of the main units is millimeters of mercury. So we're saying that 1 atmosphere, so the weight of mercury pushing down. So what that means is if I had a column of mercury in no vacuum, or in a vacuum, and the weight of all the air pushing down, it would raise this column of mercury 760 millimeters. Now, if you've ever listened to the Weather Channel, watched a weather report, and they'll give the barometric pressure in terms of inches of mercury, 29.98 inches of mercury, I believe that's correct, is the same thing. A second unit that you may see is called the torr, T-O-R-R, and we're lucky that a torr and a millimeter of mercury are one and the same. Now, when I took a weather class, I had to learn millibars. Well, millibars are related to a newer unit. I say newer because when I taught before, we didn't use it, but now it's kind of a standard unit. And I know some of the other chemistry teachers like to use it, and it is kilopascals. And you've seen that. Now, 1 atmosphere equals 101.325. It's called PA, kilopascals. And so you see that as the unit that is given to us in terms of kilopascals. So you just have to be able to relate the units back and forth. So again, 1 atmosphere equals 760 millimeters equals 760 torr equals 101.325 kilopascals. Now, how do we apply this? Well, let's look at our very first problem. And we're told that we have a gas of 12.3 liters at a pressure of 40 millimeters. What's the volume? And the pressure is increased to 0.079 atmospheres. Well, there's 2 ways of doing this. What I did was said 0.079 atmospheres. And then I said 1 atmosphere is 760 millimeters because that was an original unit. And that equals 60 millimeters of pressure. And then the next thing I do then is, and I'm going to switch sides over here so I get more working room here, is if you say then P1 V1 equals P2 V2, then you're solving for V2. What is the new volume? So V2 equals P1 V1 over P2. And here's where you're just going to have to use some of your mathematical skills. So then you go back and look at your original, the original pressure was 40 millimeters. The original volume was 12.3 liters. The new pressure is 60 millimeters. And this gives an answer to two significant digits to 8.2 liters. And so that is the first problem you have on the worksheet. If you plug numbers in, and I guess I could take just a second to do that, you would have 40 millimeters times 12.3 liters equals 60 millimeters times V2, which is your unknown. And then you would solve for that, and you would see mathematically that it also gave you 8.2 liters. So that's the first one. I'll do another video here in a little bit later, and I'll do Charles' law and Gay-Lussac's law. This is Boyle's law. It's a very important law, and so I hope that this helps, and we'll continue in a little bit.